Hi everyone, in this session we are going to discuss about can matter change its state? It is the concept of matter in our surroundings, class 9 CBSE chemistry chapter. Okay, first let's go. Yes, matter can change its state from one state to another state. Yes, in daily life also we are observing so many things like this, right? So when changing its state from one state to another state, we need to observe 3 points. What are those? What happens inside the matter during the change? Inside the matter means matter has particles, right? So what happens with the particles during the transformation and how does the change takes place? These three observations you must know. Okay, in this chapter you have to read these definitions as well because these are very important. Fusion, boiling point, melting point, sublimation, evaporation, condensation and solidification, all these are processes while the transformation of one state to another state of any matter we'll discuss clearly. So it is the schematic diagram which indicates the three states of matter, interconversion of three states of matter, in which solid converts into gas, that is called sublimation. When gas converted to liquid, that is vaporization. When liquid converted to solid, that is called solidification, and vice versa. You have the arrows indicating these processes. Yes. So for each and every definition, we'll discuss with the daily life activities along with your textbook activities. Okay. Now we'll see the first transformation, that is solid state to liquid state, which is also known as fusion. Okay, here in daily life we also observe many types of meltings, right? Ice to water, very familiar one. Then butter to liquid butter, candle melting and the plastic melting in someone. All these things are the daily life melting processes. Okay, as we discussed in the earlier slide, what we discussed, 3 points we have to observe. What happened within the material when they undergo change transformation, right? So first, with the activity given in the textbook, effect of change of temperature, how the temperature affect the change of its state. Okay, let us observe this is the first schematic diagram, and then this is the original laboratory equipment. Okay, this is the schematic diagram and this is the laboratory equipment, how it shows, how it looks, right? I want to show you, that's why I displayed this one. So when we observe the first experiment, that is A, take a lot of ice cubes. Suppose you can take ice cubes in this beaker. Okay, this is beaker, this is ice cube. Then this is burner, this is called Bunsen burner, which give you the flame. This is iron stand into which thermometer is attached to record the temperature. Okay, so first start the burner, then started heating the beaker kada, right? So when these ice cubes are melting, just record the temperature first, then continuously record the temperature when melting is completed. That means it become liquid, right? Then again stir this liquid with this help of glass rod and record the temperature again. So continuously record the temperature up to the water level is decreased here. Okay, so these are the observations you have to observe in this experiment. And what is happening inside when you switch on the burner in the beaker? So okay, when you gives the heat, what happened in the solid state, how the particles will be, they are very closely packed, right? Very closely packed. So when you give heat to this, what happened? By absorbing this heat, these these particles have more kinetic energy and move separately. They move from their fixed positions and move along like this. So the spaces between the particles increase by the increased heat. So this is the effect of change of temperature. When you increase the temperature, the kinetic energy increases, then the space between the particles also increases, then it will convert into liquid. This process is called melting. Okay, so the temperature at which this process is starting, that is called melting point. The temperature at which the solid becomes a liquid at atmospheric pressure is called melting point. That is what happening here. So continuously you are recording at the temperature and you are stirring the glass rod. Then what is happening here? Then the water, you have water here, right? You are continuously heating, giving the energy. Then at some point, some energy, it will gain that much heat, and kinetic energy increases. The particles kinetic energy increases with the increase in temperature. Then what will happen? So all these, the which are particle in liquid, become more energetic and overcome their force of attraction between them. That means the bond between, the force of attraction between the particles will break down. Then these particles will become vapor, vapor state. Then liquid becomes gaseous state. This is liquid, no? When you are continuously heating, it absorbs the heat energy, and that heat energy is more in such a way that the force of attraction, the bonds will break between the particles, and they become a vapor. That is a vapor or gas. This is called the temperature at which this process starts, that is called boiling point. Okay, boiling point. You know very well what is the melting point of ice, that is 0 degrees centigrade or 273 point Kelvin, right? Whereas the boiling point of water is 100 degrees centigrade or 373 Kelvin. Here you need to observe one point, that while recording, not in theoretical part, you are recording the temperature, right, at starting point of melting. So after some time, when whole ice cubes melted into water, no, that time also the temperature will not change. It will remain 0 degrees centigrade throughout melting process. In the same way, here also, when water started converting into vapor, you are recording some right 100 degrees throughout water, until up to water coming to this place, the temperature will be 100 degrees only. But you are giving continuous energy, right? Then where this continuous energy is going, that is what called here the hidden energy, because it absorb energy, and it has some kinetic energy, and it releases some energy in spacing between the particles. So that it is used in the beaker, in the ice cubes, in the solid, it stores some energy, that is called hidden energy. In chemical way, in definition, it is latent heat, latent heat of fusion, in fusion process. In the same way, while it converting into vapor also, in the beaker, in between the molecules, while breaking the bonds, it has some energy. So that is hidden energy here, that is called latent heat of, latent heat of vaporization. Okay, all this process, the process, a latent heat of fusion, you can say, like when 1 kg of solid convert into liquid at its melting point at atmospheric pressure, that heat is called latent heat of fusion. Okay, so the process here, what is the process? When the water molecules are converting into the vapor state, water vapors, that is, the process is called vaporization or evaporation. Okay, so this is all about the activity which shows the effect of change of temperature on its melting points, boiling points, and the vaporizations and melting or the fusion as well. Another convention, that is solid state to gaseous state. Here, there is no conventional method like solid has to convert liquid first, then it has to convert to gaseous state. Not like that. There is a conversion, like solid can also convert into gaseous state directly without converting into liquid. The process is called sublimation. That is better explained with the activity given in textbook, that is sublimation of ammonium chloride. So here is the schematic diagram which is given in the textbook, sublimation of ammonium chloride. I just try to put a lot of effort to get you the similar original diagram. When you do the experiment, this whole look is the similar to this one. Okay, so I'm trying to give you the good content, that's why I'm displaying all these pictures resembling the schematic diagrams. Okay, coming into the point here, if you take the Bunsen burner and it is the tripod stand. Then take china dish or petri dish, you can say. In the china dish, you are taking ammonium chloride solid. Okay, then put the glass funnel in inverted position. Usually glass funnel is in this shape, no? So when you put reverse, it will become like this. So at the end, like this, when you put in invert position at the top, you have to put a cotton plug, okay, because no vapors would go off. So see, this is the experiment, you have equipment you have to equip to do the experiment. When you switch on the burner, the heat continuously give to the petri dish, right? So at the temperature, this ammonium chloride suddenly are directly converted into vapors without making into liquid. So that process is called sublimation. It is the original experiment. See, when you switch on this burner or the lamp, here the ammonium chloride, which is in white color, directly converted into vapor. See, you will get the vapors here. When you look into zoom position, you can see it clearly. So here the solid ammonium chloride is directly converting into its gaseous state. That is called sublimation, the process where a solid is directly changed to gas without changing into liquid. At the same time, it has some condensation. If it is cool, then it will again deposited in the walls of this funnel. Okay, see white deposition here, that is ammonium chloride. Again, the gas is directly converting into solid. So here you can see the ammonium chloride solidified. Okay, this is what called solidification or the deposition. Here mainly deposition, gas converting into solid without changing into liquid. This is what called deposition. This is the experimental activity of sublimation of ammonium chloride. Next concept, effect of change of pressure. Like temperature, when increase temperature or decrease temperature, the matter state can be changed, right? So in the same way, if you apply the pressure, the matter state can also be changed. Then you need to question yourself the two questions, right? Do you think increasing or decreasing pressure can change the state of matter? Yes, for sure. Then what happens when we start putting pressure and compress the gas in an enclosed cylinder? Suppose take any enclosed cylinder. Enclosed means it should be open in the top, and you have taken one gas. Okay, the pressure is applied with the piston in the cylinder. So pressure is applied and increased as well. So increased and increased. Pressure is increased here. A down arrow is not indicating the low pressure. Increasing with the force, you are increasing pressure. So what happened here? The gas particles which you have in this cylinder come closer and closer to this much closer, and it will become liquid. Okay, so that means here gas is converted into liquid by applying the pressure and reducing the temperature. Reducing the temperature is also the point here. So the main point you have to concentrate is by applying pressure or the increasing pressure makes the particles in gas to come closer, and the gas will convert into liquid. Here the gaseous state is converting into liquid state. Okay, that means applying pressure and reducing temperature can liquefy gases. Okay, you can note this point. Next one, evaporation. What is evaporation? Before explaining this definition, we have to observe for yeah, I forgot to explain one more thing here. So if you have any regular in our daily life, if you have any example for this, yes, we have dry ice, which is CO2. That means CO2 solid state. That means CO2 gas is taken in cylinder. Okay, you applied certain temperature, sorry, certain pressure, that 214 to 17 bar. Okay, if you applied increase the pressure in CO2 which is in cylinder, it will directly convert into CO2 solid. So the particles in CO2 gas come closer, very closer, in such a way that CO2 gas is directly converted into CO2 solid. Have you seen anywhere this dry ice which has the temperature minus 78 degrees centigrade? Yeah, in aeroplanes, we don't have any refrigerators, right? In that place, the beverages supplied to you or the food items which are very sensitive to atmosphere. All these things stored in a dry ice container where you have dry ice and in the packets or in the form of anything, the food items are stored. This is one application, and you can find this in restaurants as well. While serving some dishes, Chinese dishes, importantly, a fancy smoke will come on the from the plate. Did you observe any time? Yeah, of course, it is not at all good for health. Okay, don't consume it at any time or anywhere. So the fancy thing, or in movies also for the effect. So these the smoky, white smoky thing, that is CO2 gas, is used in so many areas. So when you apply pressure, when you increase pressure, CO2 gas will become CO2 solid. No, when you take out the solid to atmosphere, at 1 atmosphere, it will become again the direct CO2 gas. Okay, these two are observations where we can see in our daily life, which is with dry ice for the effect of change of pressure. Okay, the next point we have to focus is evaporation. What is evaporation? Before seeing this evaporation, we have to observe or explain one thing. This state of any matter can change only by increasing pressure or by decreasing pressure, by increasing temperature or by increasing temperature. No, it can change its state on its own and naturally also. We do have some examples for this also. We do have some rivers, not rivers, lakes, some simply you can take a glass of water and put it in outside. So after some time, after 1 day or two, some hours, the some amount of water will evaporate, right? Another best example, when you dry the clothes taken from the washing machine or the after washing, it has some wet, right? It has some water particles, but when you dry it, naturally they dried up. But it is not 100 degrees centigrade. We are not heating up to 100 degrees centigrade where it's boiling water, boiling point. No, so naturally also material matter can change its state from one state to another state. These two are best examples. So that's what here it is. Phenomena of change of liquid into vapors at any temperature below its boiling point is called evaporation. Okay, you can do it a simple activity at home, taking different shapes, bowls, you can say. Now it may be glass or anything. So it has if you have taken any few ml of water in this shape bowl, and this shape bowl, this shape bowl, and this is an. So why I am placing here, why these pictures I am displaying here? Surface area do matters in evaporation. If we have more surface area, you will have more evaporation. Okay, this has more evaporation. You can observe water in this measuring jar evaporates very slowly than water in this plate. Why? Because you have large surface area. Even though in suppose in a lake or in any such a bowl or a swimming pool, you can say, so the surface area particles have high kinetic energy than the particles in lower part of the body. Okay, so if you have large surface area, large number of particles will evaporate very fast. The upper part particles evaporates fastly than the lower part particles. Why? Because here the surface area particles do have more kinetic energy. That means this is the one point. You can do this activity at a sunny day and rainy day also, and you can do this activity it placing this jar in a cupboard, placing this jar in a open area at your home. Okay, so like this. So you can place in different places these bowls in different shapes with different volumes. You can check how which water bowl has more evaporating. Okay, that means here 3 points we should note. The temperature increase in surface area will affect the evaporation, and increase in temperature, right? When you do it this in summer, you have 45 degrees centigrade, it will evaporate very easily than you have the humidity or the temperature like 30 degrees in the winters or a rainy season. Obviously you will notice the change, right? Increase in temperature, and then increase in wind speed also, wind speed, then increase in humidity also, has the effect on the evaporation of any matter or liquid, you can say. Okay. So the last concept, how does evaporation cause cooling? Yes, evaporation makes the surroundings cool. How? Let's see. Suppose if you are taking a bowl with the water and put it in hot summer, then the water will evaporate, right? We already discussed. While evaporating, the particles in this have lost some energy. Lost some energy. So this lost energy, this loosened energy is regained from surroundings or absorb, regain from surroundings. Then these surroundings will become cooler. This will give you cooling effect. Okay, when the evaporation is carrying out, the particles in liquid have lost some energy. That loosened energy, that lost energy is regained from the surrounding or absorbed from the surrounding. Then the surroundings feel, by losing energy, surroundings feel in cooling effect. Okay, so examples: acetone on palm. Acetone in the lab you can get it, or in at home nail polish remover also you can use. When you pour it on the palm, whenever you pour it, it evaporated and the palm feels very cooling effect. Why? Because the particles, the liquid which are evaporated, no, it lost energy, no, the lost energy is absorbed by our, absorbed from our palm. So that way, if you remove energy from palm, the palm feel a cooling effect. Another one, water sprinkled on roof or ground. Summer, when you in summer, hot summers, in the ground, usually water sprinkled, no, water sprinkles, then water evaporate. Whenever the water evaporate, it lost some energy, liquid over here, the poured water here, so it absorb energy from surroundings. So automatically the surroundings, whatever the surroundings you have, they, by losing energy, the surroundings feel cooling effect. In the same way, wearing cotton cloths in summer. In summer we used to wear cotton cloths, no. Why? Because cotton cloths are greater absorption in water, right? So when they absorb water, like not water here, sweat, people will sweat, right? The sweat, when evaporate, it it absorbs energy from body. That's why body feel cooler here. This is the point here. In the same way, the last example, water droplet or water bottle. When you take out a water bottle or ice cold water from freeze and put it in outside, then you will find the water droplets on the bottle. Why? Because from the surrounding it's absorb energy and condensed, or the energy absorbed from the surrounding, so it will convert into water. Okay, condensed, you can say. So these water droplets are like that. So the basic key point is the lost energy, the energy lost here by the particles are regained from the surroundings. That's why surroundings feel cooling. That's why evaporation cause cooling in that sense. Okay, simply absorption of energy from surroundings makes cooling when liquid evaporate. Okay, so in this concept part 2, I explained each and every point along with the daily life examples and the suitable pictures as well. Thanks for watching. I hope you guys like it.